So the whole of this track's called Wireless Saves the World. And it seems to me that as soon as we hear the word wireless, we tend to think of mobile network operators, and why not? They are the enormously big beasts in this jungle. And actually, I was pondering this morning as we went through the debate, because my daughter told me what was quite a good joke a while back. She said, if you want to call a family conference, walk yourself to the room where the Wi-Fi box is, turn it off, and wait for a few minutes. And we laugh because it's so true. We can imagine that, the family is so ingrained with the Wi-Fi system, it won't take very long from switching that box off till people start coming to find out what's gone wrong. Switch off the cellular and you won't have the same effect. So actually, you could argue that we're moving to a world where Wi-Fi connectivity is more important than cellular connectivity. If you look at the devices that you have, I suspect you have a lot more that are Wi-Fi connected than you do that are cellular connected. And certainly from my point of view, if somebody said to me, you have to absolutely make a choice between Wi-Fi or cellular, which one would you choose? I'd choose Wi-Fi, not cellular. So when we're having a big debate this morning about how do we get the mobile operators to provide coverage everywhere, I always wanted to shout out, why the mobile operators? Why not the Wi-Fi operators? And the same, I think, is true in the Internet of Things, that by and large, our first initial assumption is, well, of course, it's the mobile operators. They are the enormously big players here. Logically, they're extremely well positioned. They've got the infrastructure, they've got the brand, they've got the ability to market to large corporates, and apparently they've got the technology. So I want to challenge that a little, and this is the synopsis of what I want to take you through. So you'd think the cellular operators are going to dominate the IoT. But first of all, I'm going to try and show you why I think the technologies that they've got are not optimal. They kind of work, but not ideally work. And then in particular, why they're focused on a very different customer base, and that makes it very hard for them to move. And to some of the comments that Paul and others were making, it's a kind of innovator's dilemma kind of situation. They're stuck in a market that has been tremendously successful for them, is generating huge amounts of revenue, if not profit. And it's very difficult to move away from that to a market that on the face of it looks much less attractive, these dirty little devices that send tiny amounts of information and very, very little revenue. But there are other technologies. The mobile operators could pick them up and deploy them, but their track record in doing anything apart from bitpipe services is actually awful, and I'll take you through why that's the case. And so my thesis is we'll see alternative providers, at least initially, being the people that drive forward in the Internet of Things space. The track, of course, is also called Wireless Saves the World. So why have I focused on Internet of Things? Well, actually, because it seems to me that if we're looking at saving the world, what is the ills that the world suffers from at the moment? Well, it's global warming, it's an aging population, and it's an increasingly city-centric culture with all the congestion that leads to. And those are kind of the three big global challenges for the future. And those are actually potentially resolved via Internet of Things kind of applications, much more than they are via anything else. So I think if wireless is going to save the world, it's going to be more through the Internet of Things type approach than it is through SMS or Facebook or similar kind of things. And I think it'll be different operators from the mobile operators. So that's where I'm going. Let's see if I can take you on that journey with me over the next 20 minutes. So if you took a snapshot of the Internet of Things market right now, first of all, you'd observe it falls into two categories. There's kind of the in-home, in-office kind of stuff, which is short range, where Bluetooth low energy in particular, and Wi-Fi and so on have got a good track record. And if you buy your Nest thermostat or whatever, then that's going to be connected via Wi-Fi or a similar kind of short-range technology. And that's fine and appropriate for a very constrained environment. But actually, if you look at probably the majority of the Internet of Things applications, they go outside of the home. They're the smart city things, the healthcare applications that require you to monitor people everywhere they go, the vehicle telematics, all those kind of things where that sort of short-range stuff doesn't fit. So if you need that at the moment, you have to go cellular. It's the only technology that there is out there that provides you wide area connectivity of a form that's suitable for that sort of thing. So if you want to have your device in your car that monitors how you drive for insurance purposes, that's cellular connected. If you want your vending machine to be connected, you use cellular. So you could look at that market and say, well, it's clear then, surely, that cellular has got that all sewn up. Pretty much everything in that space is cellular. Why shouldn't that be the case going forwards? And the mobile operators are clearly making a strong play. You only have to go to any of the Mobile World Congress and you see enormous stands or whole halls set aside for Internet of Things kind of applications. They're in this space, obviously. They're big beasts. They've got lots of money. So that kind of first pass, I think, would lead you to think it's clearly going down that particular route. But cellular isn't ideal for this space. So if we come back to the Internet of Things, it's really all about connecting sensors to databases in some way, shape or form. These things typically send some sort of information, like somebody's opened the pillbox to take a pill out, or here's a meter reading, or a car has moved into this car park space. Now, sometimes you want to send something back, for example, to actuate we talked about a water supply for a sprinkler system. But for the most part, these are just devices that send a bit of information. It goes to some central processing node, potentially in the home, more likely in the cloud. It does something. If it's a car parking space, it aggregates that information, and then when someone says, I'm coming into Cambridge, it says, here's the set of all the free car parking spaces. I've allocated you this particular one. So that's what the Internet of Things is about. And sensors are simple. There are goodness knows how many in every cell phone. We have no problem making pretty much any kind of sensor. The problem is getting the information from the sensor back to the network. And if you look at most applications in the Internet of Things space, they've got 4 requirements. First of all, they've got to be battery powered for a long time. You don't want to be changing your car park sensor batteries every week, and you certainly don't want to be recharging your smart dustbin every night. 10-year battery life is kind of the oft-quoted norm. 10 years, it's a random number, but it's got to be in that kind of field for it to work for long enough. It's got to be pretty cheap. If it's going into your dustbin or whatever, then it's going to have to be $1 or $2 for the bill of materials for the radio part, nothing more than that. It's got to have pretty good connectivity. So you don't want to be the council that rolls out the smart dustbins and then finds that only 50% of the people's dustbins can actually find a wireless network, the other 50% can't, because then you've got a solution that doesn't work on a large scale and you get a lot of annoyed people, either because they are connected or because they're not connected, depending on how you see smart dustbins as a good or a bad thing. And ideally, it's got to be global because that delivers economies of scale, but also a few applications require that. So asset tracking is typically global. And vehicle telematics, even if the vehicle itself is not going to drive right around the world, you ideally want to ship it with one kind of spec, regardless of which country it's going to end up in. So that's what we're looking for in terms of wireless networks. So how does cellular stack up in that case? Well, so-so is the answer. 2G, it's probably 2 to 5 times too expensive. Battery life, you can get it to go for a few months if you're really careful on GSM. You may even be tweaking it out a bit further if you try really hard, but it's not quite there. And coverage, well, we heard about that this morning. It's not bad, but indoor penetration from a typical cellular network, actually Simon's covered this in quite a lot of detail in various studies. It's sort of in the low 90% from one cellular network. So not bad, but not ideal. But the problem for cellular is, of course, it's going in the wrong direction, and you can see why there. 4G, fantastic for us, people, terrible for machines, absolutely the wrong thing. Machines don't want higher data rates. In fact, lower data rates are better because then you can have a simpler, cheaper core processor that runs on lower battery power and costs less. And your smart meter doesn't actually care whether it delivers its data at a megabit a second or a kilobit a second. In either case, it still gets it done in a fraction of a second. It's utterly irrelevant. Now, you could say, well, OK, that's fine. Let's just stick with 2G and tweak it a bit. Well, 2G is now 30 years old. If you're going to put this stuff into a smart meter, most smart meters you'd expect to last for 20 years. It's going to be 50 years old by the time that finishes. Imagine running a PC that's 50 years old. I mean, this stuff is going to become pretty difficult to support and run with. And the cellular operators will be wanting to farm that spectrum at some point into something that is vastly more spectrum efficient. 4G, from a spectrum efficiency point of view, is orders of magnitude better than 2G. So it's a huge lost cost opportunity to run it on 2G. So it's not a great fit. And what about the customer model? Well, you know most of this, but you can see some of the enormous differences here, and the most obvious one is in the ARPUs, that these machines are going to be very, very low cost. And right now, companies like Jasper are actually making their money on diverting traffic from the core network, because the cost of a billing record in the billing system is more than the revenue that you get from the Internet of Things device. So if you can keep it off your billing system, then you're actually saving money. Now that just shows you the problem with such a different cost model. It's not that the billing system is a bad thing. It's perfectly good for what it was set up for high revenue people doing lots of different things that need complex billing arrangements, but it doesn't work for the Internet of Things. SIM card, the whole question is, should we have a SIM card in a machine? What does SIM stand for? Subscriber Identity Module. Which subscriber are we talking about? Not one that I can think of. It's a machine. It doesn't want to change its SIM card. And you can see, a number of other features there. Small messages in particular is a key one. So most machines are sending a byte, 5 bytes. A car has entered my space. And yet, if you use something like GPRS, by the time you've woken the thing up, gone through the attach phase and everything else, you've sent about 500 bytes of data. That's about the minimum you can send from a whole kind of wake up attach process to a send back to sleep process. So you've got 100-fold overhead on messaging from small machines. Is that going to scale when you've got 50 billion machines? Not very well. So there's a lot of differences here, and some of those differences are pretty critical. Now, that would all be well and good, but rather irrelevant if there wasn't anything else that you could adopt. But of course, there are other technologies, and as many of you know, this is the one that I'm deeply involved with. It's called Weightless. Most of you heard of it. It's designed specifically for machines, and it's designed to meet those particular requirements that I set out at the start. And it does that by deliberately not meeting the requirements of people. So it throws away high data rates, it throws away seamless handovers, low latency, the ability to contact things very quickly and frequently. And if you get rid of all of that, you can make a lot of simplifications which actually allow you to meet the battery requirements and the coverage requirements and other such things, but in such a way that you have a technology that is utterly, utterly unsuited for people. Completely different technology space. And you can take something like this and you can even deploy it now without a license. Now that's quite critical for what I'm going to say later. So Weightless and a number of other Internet of Things technologies, proprietary and otherwise, have been designed typically to run in unlicensed spectrum. And there's pros and cons of unlicensed spectrum, and we haven't got the time to delve into them here. But what it does mean is that an operator can just pick it up and deploy it pretty much straight away. They don't have to wait for an auction process and go through that whole buying of spectrum problem. And that does allow others into this particular space. So, why don't MNOs pick up Weightless or something similar and deploy it? Of course, they could. There's nothing to stop them doing that. But let's take a look at their track record. Have a look at that list there. Remember all of those? Video calling. That was certainly something that a number of operators tried to do with 3G. I think that's Skype that has that one sewn up. Group calling, well, not really cellular operators. Picture messaging, yes, they tried that one too, didn't they? I don't think many people use the picture messaging app within their cell phone anymore to send pictures. Location-based services, yes, they were going to control that market by controlling all the data about your location. Google found a good way around that with Wi-Fi data and other such things, and they've lost that one. Walled gardens, widgets, WAP, remember all of those? E-health is a more recent one. Mobile payment, O2 just recently, or Telefonica has recently shut down their mobile payment unit because they weren't, well, they're in the e-health unit as well because they weren't getting anywhere with either of those two. And it's not because they're stupid or they're bad or anything. They're extremely good. They're fantastically good at delivering what they deliver, which is basic connectivity of voice and data to billions of people in a way that is reliable, solid, and really does work well at a cost that frankly is pretty low for what they provide. So I'm not being critical of them, I'm just pointing out that they're not particularly good at deviating from their core basic underlying business model. So could they do the Internet of Things? Yes, they could. Are they going to succeed? Track record to date suggests possibly not. So who might? Well, there are plenty of others out there who are looking at the world of wireless and saying, we'd like to be in this world, please, and have been doing so for quite some time. And in some ways, they've got the advantage of not having to worry about cannibalizing existing revenues that they're getting from GPRS type traffic, of having a particular technology base that they want to try and stay on the same platform. You know, if you're a cellular operator, ideally you want to roll out something that is a 3GPP standard that you might think will come in the same software load as your 3G and 4G stuff and go onto the same base station for very good reasons, very sound business reasons. But if you don't have any of that stuff, then you don't have to worry about going down that particular route. And the cellular operators have got big advantages in terms of sites, but actually, do they own the sites? Well, not always. A lot of them are leased or rented or owned through a third party. Others can access those sites, and others indeed are site owners. And actually, sometimes you don't even need sites per se. Things like supermarkets or petrol stations or something that's well distributed around the country is adequate. And some of you have already seen my business model of what it takes to deploy a UK-wide network using Weightless technology. And it is circa $100 million if you have the sites already or can access them without having to go build greenfield sites. And that's not an insignificant amount of money, but equally is not the amount of money that's beyond medium or large companies, or even a particularly well-funded startup, at least a Silicon Valley funded startup, if not a UK funded startup. So it's not a game where you have to be a really big player in order to enter this particular space. So to sort of conclude on this, you know, if you look from the outside, I think you might initially think, as we did this morning, wireless means mobile network operators. But cellular isn't really a good fit to the Internet of Things. There are other technologies that are better, Weightless, and as I said, plenty of proprietary technologies in this space as well. And for good reasons, the mobile network operators want to try and fit something that comes through their existing standards process. But there are plenty of others that are hungry, and you only have to look at announcements like the Milton Keynes trial that BT are involved in, for example, to think of other players in this particular space. Now, things can all come back together again, and mobile operators can acquire other companies and so on. So it may well be that by the time we get to 5G, as many have set out a vision of 5G of some all-encompassing system that involves the Internet of Things and cellular traffic and Wi-Fi connectivity and others, that it will all collapse back into one complete system. But my premise is that until then, we will most likely see others than the mobile operators taking the lead in deploying Internet of Things traffic and systems around the world. And I think that's me done. Yes. There's some more information on Weightless if you want it. Thank you.
Thank you. Any questions?